Hello, this is Dr. James Camp from Lee College in Baytown, Texas, and this is the fifth lesson in my Starting Off in C++ series, where we're going to discuss writing your own functions. Today's project is going to be a simple banking app. Okay, we want to write a simple menu-driven banking app that really only handles two situations. The user can deposit money or they can withdraw it. To keep the main portion of our code clean, okay, that is really simple and easy to read, we're going to implement each of the two situations, deposit and withdraw, as a separate function. Now, as always, we're going to start by setting up the program. We want IO stream because we want to do console input output. We want IO manip because we want to force the program to round your currency to .00 or .34 or whatever, dollars and cents. And we want to pound include string because we're going to use a menu. We're going to define the menu as a constant string. Now, function definitions in C++ follow this interesting syntax that's borrowed directly from standard C. Okay, there's a return type and a function name. So far, it looks exactly like defining a variable, right? You have a type and then a name. What tells C++ that you're defining a function is that you're then going to have an open parenthesis and a close parenthesis. You don't actually have to have any parameters in between. Most functions are going to take some, one or two parameters, but you can have as many parameters or as few as you want. You can there are cases where you'd want a 0 parameter function. For example, if you're programming a robot, you might have a function stop that just halts the robot in place. It doesn't need any parameters. It's just going to stop. So in that case, it would be void stop, open parens, close parens, nothing in between the parentheses. Then you're going to have curly braces. Unlike if statements and while loops and for loops, there is no option to leave off the curly braces if you only have one thing for the function to do. You've got to have the curly braces, and then you're going to have a list of things for the function to do, a list of lines of code that the function is going to perform. And the last line of code that gets executed is the return statement. You can return a variable, you can return a literal value, or you can return an expression that is x plus 5 or value minus adjustment or whatever. As long as that variable, value, or expression is of the correct return type. Okay, you can't return a string in a double type function. Okay, so going back to writing our program, the next thing we're going to do is prototype our functions. Okay, the first two, deposit and withdrawal, are going to calculate the actual deposit and withdrawal. They're going to calculate the new balance in the situation of a deposit or a withdrawal. The second two are going to handle the user interface for deposit and withdrawal. And they're actually going to call the first two functions. So we'll have main calling do deposit and then do deposit calling deposit. Notice that in this case, I ended each of the functions with a semicolon. Okay, that tells C++ that this is a function prototype and that we will fully define the function later in our code, in this case, after we write the main function. The ampersand means that balance is going to be passed by reference. Okay, that means any changes we make to balance in the do withdraw function are going to reflect back to the calling function, which in this case would be main. Finally, the void keyword here means that this function does not return a value. It's going to modify balance by passing balance as a reference parameter, and so it doesn't have to return any value. And we'll see how that works, how we call that function in the code. Okay, now we can start writing the main program. First, we're going to set up some data. We want a global constant starting balance is $1,000. We're just going to assume that the person has $1,000 to start with. Obviously, in a real banking app, we would look this up from the bank database or something. Constant double overdraw fee, $25. If the person tries to withdraw funds that they don't have, we're going to take $25 out of their account for an administrative fee. Hate it when banks do that, but we might as well simulate it in our bank too. Okay, then we have int main, and we start with a double balance equals starting balance. Now we're going to set up the menu system. We have a constant string that I call menu string. It's going to say welcome to Simple Banking, then a new line, then the menu itself. 1 for deposit, 2 for withdrawal, 0 for quit. Then we have something called a do loop. A do loop is always executed at least once. Okay, it's called a post-test loop because we run the loop once and then test the condition. This is very handy for text menu interfaces because the menu has to be printed at least once for the user to be able to tell what they want to do. Even if all they want to do is say, oops, I didn't mean to do this, and quit, they have to see the menu once to do that. So we're going to see out menu string. We're going to see out fixed and set precision to 2 to make sure that balance gets printed as in currency format. Balance is balance. I probably should have put a $sign in there. And then we print a little arrow indicating that it's time for the user to make their choice. Then we see in the choice and we handle the choice here. And we're going to do this while choice does not equal 0. So as soon as they choose option 0, we quit the program. Finally, we can replace the handle choice here comment with a switch statement. Right after the CN choice, we do a switch on choice, and if they chose 1, we call do deposit of balance. In case 2, we call do withdraw of balance. In case 0, we print a thank you message in the program. And if not, we print that that's not a valid menu choice, and then we cycle back and print the menu again. Now, always remember when you're doing switch statements to put your break statement in at the end of each case so that the action doesn't fall through to the next case. We don't want to do a deposit and then do a withdrawal. We just want to do a deposit. Okay, our main program is done. See how simple that is? Now we get to go define those functions. Deposit is really easy. There's no special cases. We just add the amount and return the sum. So the one line of code in the deposit function is return start balance plus amount. Withdrawal, on the other hand, needs to make sure there are sufficient funds. So we're going to have an if statement in here. If amount is less than start balance, okay, then we have room to make that withdrawal and we return start balance minus amount. Else, we're going to return start balance minus the overdraw fee. Now here we probably should print some sort of a warning statement to the user saying that they had insufficient funds and were being charged a fee, but I didn't want to make the code look any messier than it already does. So those are the two calculation functions. Now let's look at the interface functions. Note that functions, even though you're passing them arguments and they're possibly returning values. This is a void function, so it won't return a value. They can also do regular console I/O. So this function can ask the user to enter a deposit amount, and the user enters the amount. And then functions can call other functions. Okay. The new balance is calculated by our calculating function, deposit, which then returns the new value, in this case, to modify the parameter value balance. Okay. Finally, note that there's no need to return balance this time because balance was passed as a reference parameter. So any changes to balance here will change the balance that was passed by the main program. The function for do withdrawal looks almost identical, except we change the text, the prompt text, and we change which calculation function we call, obviously. Okay, so here's some sample output. Welcome to SimpleBank. Your balance is $1,000. I choose 1 for deposit. Choose to deposit 123.45, and you see that the balance change did reflect back to the main program because the main program now says balance is 1123.45. Now I choose to make a withdrawal, and I choose to withdraw more than I have in the bank. So you see that it subtracts the penalty amount instead, the $25 overdraw fee, and my balance is now $1098.45. Okay, so in summary, what we've learned today, we've learned function definition syntax in C++. We've learned the unique function prototype syntax in C++ that lets you prototype a function at the start of your program and then write the function later. We've learned do loop syntax that's very useful for menu-driven programs. And we've learned how to pass variables by reference so that changes made in the function will reflect back to the calling function. Okay. Plenty of opportunities out there for you to practice writing functions. I'll have an assignment for you posted on the Blackboard site by the time you've finished watching this. So go to it. Good luck and happy programming.